That means yes.
Yeah. Okay. Slope of a curve. Okay. The blue graph is a curve. What's the slope right here?
1.
The slope is 1. The rise over run right at this point is 1.
No.
Meh. No.
Absolutely
No.
not. I was right.
So, let's figure out how to find the slope at this point. So let's start with the point 1, 1 and 2, 4 here. Let's find the slope of the line that would like go from here to here. Okay? From there to there. Okay. Now, if I could draw a line from there, I wonder if I can draw a line on Desmos. Let's see. Draw. No, I can't draw. Obviously it's not.
The blue one, you're telling me is x squared?
The blue one, y equals x squared, is a function. I'm looking for the slope at the point 1, 1. It's a parabola.
That's what x squared makes.
Yeah, that's what x squared makes, is a parabola.
I'm not talking about that. That's what we're trying to find. The slope is talking about what
We want the slope at the point 1, 1. So I'm going to go from 1, 1 to 2, 4, because those are 2 points on that blue line. Okay, let's go back to there. So Trey knows what's going on. 1, 1 is this point. 2, 4 is this point. We're going to find the slope between those two. Okay? I'm glad you get that, Trey. So the slope between these two is 4 minus 1 over 2 minus 1, which is 3. Okay? Slope is 3. Now, let's not go there. Let's go at like somewhere closer, like 1.1. So if I go 1.1, well, I don't have my keyboard. 1.1, come on. 1.1, my y would be 1.21, because 1.1 squared is 1.21. So if you look at this, the slope between these 2 points and the slope between these 2 points, it's a little more accurate the closer we get, right? Okay, correct. I'm glad somebody believes in what we're doing here now.
We literally just this.
Okay, so if I have 1, 1, and then 1.1, 1.21, the slope will be 1.21 minus 1 over 1.1 minus 1, which would be 1.21 minus 1 would be 0.21 over 0.1, which would be 2.1. Okay, that's a little more accurate, right? Well, let's see even get more accurate that yet. Let's go 1.01. Somebody, 1.01 squared. 1.0201, right? Okay. So the slope would be 1.0201 minus 1 over 1.01 minus 1, which would be 0.0201 over 0.01, which would be 2.01. Okay, this is like a limit problem. The limit as the change in x is going towards 0, because see how my change in x went 2 the first time, then 0.1 the second time, then 0.01 the third time. I'm getting closer and closer to change of x of 0. As that is getting closer and closer to 0, the limit of x squared, or the function, is getting closer and closer at the point 1, 1 to 2. Okay? So the slope at the point 1, 1 would be 2. Okay? So we're going to be looking at slopes coming up here and figuring this out. Now, the slope at 1, 1, is that the same as the slope at 2, 4? And everybody is in agreement because you guys are all bright, conscientious students. Okay? 2, 4. And let's go to the next point on the graph, which is 3, 9. Okay? What's the slope between 2, 4 and 3, 9? Well, it's 9 minus 4 over 3 minus 2, which is 5 over 1, which is 5. Right? Slope is 5. Okay? So let's go from 2, 4 to 2.1. What's 2.1 squared? 4.41? Okay? So slope is 4.41 minus 4 over 2.1 minus 2, which is 0.41 over 0.1, which is 4.1. What do you think the slope is going to be? The slope is going to be 4 there. Okay? The slope is going to be 4 there. So we can figure this out for any point on any function. Okay? By using the slope formula. Now, what are our 2 points? Well, one point is going to be x and then y. And then we're going to have a change in x. And then we're going to have an f of x plus the change of x. Okay? Because x is going to change so much. And then you got to put that number into the function. Because that's what we did with this. Put the x into the function, the new x into the function, and we figured that out so we could find the slope, right? So if you find the slope is f of, and then instead of having a y here, we'll call it an f of x, because f of x is y. We know that from our years. So f of x plus change of x minus f of x over, this should be x plus change of x plus change of x minus x. Well, can we simplify this at all? And the answer is yes. It's f of x plus change of x minus f of x over the change of x, because x minus x cancels. And this is our function that if we take the limit as change of x approaches 0 of this function, then we can find the slope of any curve at any time. In college algebra, how many of you took college algebra? This is called the difference quotients. Difference quotient. So I only saw a couple hands go up for college algebra. How many people actually in here took college algebra? 1, 2, 3, 4. Next semester? Okay. You were too smart? Mr. Ricky, if you were actually smart, you would have taken college algebra last summer, when you didn't have a job.
Okay, that's a violation. We gotta stop there, Mr. Bishop.
When
I was studying for this class.
right.
Right.
When you didn't have a job and you could have taken a college class, which would have saved you over $1,000 for your, if you go to college and take it.
No, actually.
Actually, it's about $1,000 nowadays. But are you going to take it sometime this school year, or are you just going to, nah?
That's Breeze. Breeze didn't take it.
Take it
But
over
I
the
didn't
summer.
claim I was smart enough.
Yeah. You can take it, but it's still it's still price. But you can still get it done before you go to your first semester at college.
Well, you can, but once you graduate high school, it's going to cost a whole lot more.
Even I'm doing it, and look at me. Look at
All
me.
right, so no, Nate, I'm not trying to pick on you, so too much. Okay, so what you're dealing with for quite a bit of this chapter is slope. Okay, working with slope, but it's going to look really strange sometimes. It's going to look like this. Okay, and for most of you, that doesn't look like slope. Okay, that doesn't look anything like slope, but that's what we're doing, is finding slope when we do this. Okay, some of the slopes will look very normal, and you won't have a problem with it. Okay, so what I'm going to do is unleash the first set of stuff to you before lunch here. So it's not too bad. I mean, I got them done in a matter of, well, not the videos, but the problems. Each set of problems I was done in like 2 minutes each. So the problems aren't that difficult. Of course, I have taught Calc multiple years and kind of know what I'm doing, but